you are.
Yeah.
I
I was saying I love the eagerness to join the meeting this afternoon.
well, I noticed I originally thought it was from 4 to 5, and I have one of my last official robotics meetings. We
Yep.
compete on Saturday, so I will have to bugger out early to get over to that because we have a lot of work to do
Okay.
to get ready.
Well, you have a little bit of time to get to know this guy from Bdager Meter.
Yeah, because I am very interested in working with them and having them work with our school, whether it be in the classroom or through Green Team, where they can help us do like some assessments. That would be really cool. So thank you for coordinating this. I appreciate it.
Well, they're officially a supporter of the Fellows program.
Right.
So, they're looking for how can we get something back out of our support?
Yeah.
How can we make it mutually beneficial?
For sure. Yeah. This is nice though to have that kind of scheduled time with them to meet and coordinate some things.
Do you think we should try to do that more often with other program partners?
I think that is a good opportunity. Like that was one of my make sure, I told them I was going to be late to robotics and I wanted to make sure I was able to have that conversation because I know we did have a brief conversation when they came to join us during one of our last presentation days, and we were able to connect. But this is nice too. So
well, I mentioned it's what now that you're sort of underway with things, you have probably a better sense of what could be useful and
somewhat.
It's
the school year is definitely in full swing, and usually the frantic, I'm overwhelmed and drowning feeling doesn't start until a little later in the year, but it hit nice and early this year. But I really enjoyed my experiences working with Bev. That has been awesome. And Yost, I know you were able to come down to the river with us that one day.
Yeah, that was great. They had quite a few volunteers out there.
Yeah, that was absolutely amazing. I would definitely coordinate it a little differently for next time, where we would maybe just do some other activities at the park and not try and squeeze it in such a short amount of time. So to give them more time to do that kind of work is important.
Yeah, you're capturing those sort of reflections on how to do things different.
Everything down. And I guess I don't know how to post things in the learning thing. So
I like that poster. Einstein asked questions.
Oh, yeah.
He wasn't just a genius that knew everything.
Yeah.
He knew everything because he was asking questions.
Yeah. So who are the other volunteers that were there when you were there?
Could be some retirees, either from the Nature Center or from other types of environmental organizations that still want to be involved, but not full time.
So the River Edge brought them? Or they came from the school?
No. From River Edge and Weir Nature Center brought them. Yeah.
Oh, that's great.
So those types of retirees, not retirees that the school knows.
Yeah. Oh, cool.
I want to say there were probably at least 4 or 5 of those people, and then of course I need to know Carly, who just started there.
Yeah.
She was out there too, volunteering.
Yeah.
So it was a good crew.
That's great.
It's just, things are crazy, and I'm trying to hold on and push through some stuff. With our 2 short weeks, I did postpone. We're going to do some follow-up work on our water testing next week. I still have my MSOE tutor coming. He's awesome.
Oh, terrific.
He comes once a week for 1 class. And he just said that at first he only had so many vouchers, but they said that he said they replenished his vouchers for his Ubers to come here.
Yeah, they've got plenty of funding for.
Yeah. Oh yeah. Well, at first he thought he was done in November. He thought he was done mid-month, and he's like, "Oh no, I get to come longer." So that was good.
Yeah.
I'm letting Matt Duyvenberg in.
Oh, good.
So how's everything with you guys? Good?
Yeah.
Busy.
Just juggling everything, right? Just like you guys.
Yeah.
Hello, Matt.
Hey, afternoon, guys.
How are you?
Good. Yourself?
Good. So Jennifer jumped on early because she's got to get to a robotics thing. Jennifer, do you want to do a brief introduction on?
Yeah, sure thing.
Yeah, go ahead.
Or what would you like me to focus on?
Well, I was going to say, who you are and what you've been up to.
Okay, perfect. Yeah. Hi, Matt. So I'm Jen Clark. I'm an 8th grade science teacher over at Glen Hills Middle School. I do also run the green team as well. And we are considered a green school. We have a LEED award and a couple other ones too for some of the work that we've done. And with the water work that we've been doing, we've been able to do some studies with the Milwaukee River, partnering with the Parks Department and doing some water quality testing, as well as some biotic index testing where kids are able to get in the river and collect some water. So we're still at some of the beginning stages, but as the year continues on, we do want to take a look at more water quality testing, both out in nature and like in our building, and take a look at what that might look like. And then as the year goes on, one of our capstone projects is to kind of do like a revamping of the city with adding in more green infrastructure, like a redesign, adding green infrastructure, but then also looking at how can we make our water systems more accessible, equitable, and cleaner. And again, with that kind of green infrastructure, how can we also use it more efficiently? So that's kind of the projection. I know one of the things I was interested in connecting with you on, I know one of the earlier meetings, there was a representative from Bdager that talked about doing like a water testing or evaluation of like our school. And then that's something that your organization might be able to help us with when it comes to, how does our school building, how efficient are we at using water? How can we do things better? I don't know what else you could possibly help with any of those things, but that would definitely be something I'm interested in as well.
Okay.
Thanks. And then Michelle Young, also from Glen Hills. Michelle, do you want to give a little update on what you've been up to? And Matt will maybe have a better sense of where to go with it.
We're still at trying to define and understand how to measure the quality of water. So the students have, they've done some water quality testing, but indoors. So they were not able to measure use as many variables as Jen. Jen went outdoors. They looked at some things. Our next thing that we are doing is we're going to have them research some of the variables that they looked at. And then from there, we want them to actually design some type of mechanism where they can monitor one of the variables, maybe a sensor for dissolved oxygen or for pH level or something. So we're more interested in the designing process after the kids get a clear understanding of water quality testing. So that's what we're looking at.
Yeah, and so Michelle has 6th grade science students,
okay,
and Jennifer's 8th grade, right? And Susan, do you want to do a little introduction of who you are and what you're up to?
I have to.
Yeah.
Hi, everybody.
Hi, Susan.
Hi, Susan.
How you guys doing? I'm at King Middle. I'm running the innovation lab here. So I do not have a schedule that I'm with certain students every day or every week. I worked with 7th grade first mark period. I'm working with 8th grade this marking period. So I'm trying to collaborate and coordinate with teachers, but there's just a lot of variables happening in our school where so many staff members are out, and it's not that they don't want to work with me or collaborate with me. So I'm just really trying to make gains here and pull students here, but there isn't that real authentic connection to what they're working on in the classroom per se.
And then, Matt, do you want to do a little introduction and what you're up to, and then?
Yeah, absolutely. So no, I appreciate the opportunity to speak with you all. Sounds like some interesting stuff going on already with students, and I love engaging at that level. So I work at Bdager Meter. I'm Senior Director of Water Quality at Bdager Meter. I've been there for coming up on 15 years, mechanical engineer by undergrad, executive MBA by secondary degree. And I had been director of engineering previously, working on all of our flow metering and telemetry and data backhaul and automatic meter reading infrastructure and everything else. So really 2 years ago, I took this role in water quality and built out a strategy on how we're going to bring water quality into really more analytics around distribution system water quality monitoring alongside of all our flow metering offerings. So Bdager Meter, 115-year-old company, flow metering, really primarily residential, commercial, industrial flow metering for billing. Moving beyond that, leveraging all that data we're collecting to help really optimize both water distribution networks in both pressure, temp, flow, everything else, and collection networks. So we've now acquired 2 water quality companies over the last year, ATI and SCAN. One of them specializes more in optical spectrometry measurement of water quality parameters, the other one in electrochemistry. So things like you already mentioned, pH, DO, a few other parameters. So I can go over parameters and go over a number of things on what we do. We have a water quality lab in downtown Milwaukee where they actually develop the back end electronics for those water quality sensors. So the membranes and everything else are developed out in Pennsylvania, but the electronics for all the amplification and data backhaul and everything else is done in the Third Ward. We have software platforms for aggregating all of that information so you can see it. So even Jennifer, going back to your comment about the building and optimizing your water quality or usage or whatever else within the building, we'd have platforms targeted at kind of commercial or building or school or whatever else for water quantity and water quality, inlet, outlet, effluent, whatever else. All of this is kind of new for us. We're certainly in the integration efforts of bringing these companies together into the broader Bdager Meter offering. So some of this teams are small, whatever else, and we don't really do testing. So it's really more installed products. It's not that we have a test lab for the sake of someone sends in a sample and we're going to tell you what's in your water. We're not lab services. We're more installed instruments. So we've got instruments in wastewater treatment plants, in lakes, rivers, whatever else for monitoring of environmental contaminants or environmental changes of conditions, or inlets to water treatment plants, in distribution networks, in industrial effluent, so monitoring for pH violations that might be coming out of an industrial user going into a sewer network. But it's not like you'd be able to send us water and we'd tell you, 400 parameters that are within it. We don't do lead. We don't do a number of those other items. So that's a 20,000 foot view of kind of what we have and what we do. Before diving into anything else, I just wanted to give you a little taster on kind of what we have and who we are, and see what you guys are looking for. Because I think a lot of the topics are interesting and finding really what fits without just kind of rambling on as well.
Yeah, so we talked with Matt probably about 2 or 3 weeks ago now, and thought it'd be good to foster a conversation with you guys to sort of see where there are useful connections. What would you like students to see? What are they working on that it might be useful to sort of help make that real world connection with some of Matt's folks. And Michelle, I saw your eyes light up when
well, it did when he talked about the water quality lab. That's interesting because I think sometimes students will need to see what, even though you said install products, sometimes students will need to see what exists and how can they take that so that they can make something else from that. So I was interested in that water quality lab that you mentioned.
Yep.
I can imagine that there might also be some interest, not only in the products or what you're testing, but thinking about the lab and product development. How do your engineers go through the process of we really should have a sensor for this or a product for this. How do we start? How do we test it? How do we develop it? Iterative prototyping and that type of thing. Is there something that could be accessible or could be described for the teachers and their students? I understand there's probably a lot, that's like, no, this is internal stuff. We don't talk about that because that's our secrets. But is there a level that you could share or work with, the students, or maybe your colleagues could work with the students as they go through this process that's probably very foreign to them at this point?
Yeah, and certainly we've done that before. In general, I think that falls into more just general mentoring on product development, right? So whether that's even, doing something like Lego League or whatever else, there's kind of a thought process that goes through with some of those STEM forward sorts of activities on how you identify a need, how you start building, prototyping, whatever else. Yeah. Certainly within our walls, we have a new product development procedure, which we're pulling in field insights to generate a marketing spec, to then create an initial design spec, to then build first prototypes. And so can absolutely walk through that stuff in more generality too. And whether that, any of our engineers or project managers or whatever else could certainly speak on those topics.
Well, I think the other one that I think gets interesting is you talked about having sort of the dashboards to sort of monitor stuff. So how do you communicate the data that you're collecting in an effective way that allows somebody to understand what's happening? And I think, as you're looking at having the kids play with IoT sensors to, gather some data, well, then how do they share that?
Or even
in a useful way. Yeah.
How do they compare it to other things? Like you had said that you have some installs in some of the rivers, and you're monitoring like inflow, outflow from places, even like factories and things like that. Like I would be interested in getting hands on some of that information. And maybe if it's from years past or what have you, just so that kids can kind of see like, well, what are the reasonable levels? And if we're testing with the Milwaukee River, like, do we have other data on that? That's fairly current, and that would be interesting to look at too.
Yeah, and Riverkeeper should have a bunch of that data from their
they have
their prior testing. But
Is Adrian coming up?
Yes.
How are you, Adrian?
4:15 or 4:30, right?
Whenever you're able to join, Adrian, anything's good for you.
All right. My calendar is, I don't know, it
Screwed
says
up.
4:30. Here's where I am.
Yep.
So I did just put in the chat window a link to H2 Now Chicago. It's not actually our sensors, but it's a program of which I think is really cool and I want to see more of, but it's just direct public information for river monitoring data. So that's in the Chicago River. Aggregate sort of value, tryptophan is what they're measuring and putting out there, but it's that sort of information of which I think becomes powerful when the populace knows more about their water quality, even if this is just the Chicago River, of which everyone assumes is polluted, kind of like we kind of assume the Milwaukee River is not, but it's something we're in some basic talks with as well to get put into some of the Milwaukee waterways on how do we make some of this more public. Once you make it public, I think it drives then action to making changes into what's causing the pollution in the rivers as well.
So are you aware of anything like that happening in Milwaukee at the moment, or is this brand new for Milwaukee?
Not right now. It's something of which I saw some stories come out a year or two ago about them wanting to clean up the river, of which we were just kind of on the forefront of our acquisition process. So it was kind of earmarked for me to come back to those people in the city to look at how do we implement some of this? How do we drive more of a culture around water visibility?
Adrian, Adrian and Lalitha joined us. Lalitha is also with Glen Hills, and Adrian is with Audubon. Do you guys want to do a quick introduction of yourselves?
Sure. So I'm Adrian Wade. I'm the GE Innovative Instructor for Audubon. We are a 6th through 12th grade school. And so I was I am still a Learn Deep Fellow from August of this year. And we launched a a water project. So like I'm only working with the sixth graders right now. And so far we've done the introduction part. We had a presentation by the Freshwater Toolkit organization. And right now we are looking to have a field experience around collecting water samples and measuring for what qualities, I don't know, but we have the Alverno College across the street from us. They have a stream, technically it's a stream. So we're gonna measure water from their stream, sample water from there, sample water from their kids' favorite fountain in the building, the tap water in their classroom, measure it for what I don't know. I'm interested in this meet right now because apparently there was a way to measure water qualities using light sensors or something. Did I miss that somewhere? So I'm interested.
You can, yeah. So
right now, there's a professor at Alverno who's trying to get a kit together so we can have a field experience so they can collect this data, right? And then we're gonna come back and for just like the math component, measure how much of it we need to get a regular viable sample. And that's kind of where we are with it, you know?
Thanks. Lalitha?
I'm Lalitha Murali. I'm a gifted and talented coordinator for the school district of Glendale. Both my colleagues are here, Michelle and Jennifer. So what we have done so far is from Milwaukee River Keepers, representative came and worked with all of our sixth graders, and they did all the testing of, pH, oxygen, nitrate, phosphate content, and everything with the 90 plus sixth graders in class. She just brought in the Milwaukee River sample when she came. And we took the entire 138 graders to Clutch Park, Milwaukee River, where Bev from
Where Nature Center.
Where Nature Center came with her volunteers, and they did the water testing there, so at the site. In our school, our goal is 6th, 7th, and 8th grade, over 300 plus students will be doing the water quality testing. That's why we wanted to join today, because if we could get some of your, because that's our goal, so by end of this year, our students will know about the clean water, the journey, and then they will create a prototype, and then they should be able to use their prototype to test the water quality, so that's our goal. And I missed, for some reason, I thought 4:30 is our Zoom meeting. I'm sorry, so I just missed. I thought I'll quickly come back. I'm an Indian from India. Today is our festival Diwali. Mm-hmm. So I left too. So I'm going to just be here for a short time. And then because I didn't want to miss your presentation and learn about Bdager Meter, how we can use that to provide that opportunity to our students. So that's why I'm here, but I may have to log in quickly so that I can dress up and go to the Diwali function.
Mm-hmm. Okay. Yeah. Appreciate you making it for a couple of minutes.
Yeah, and I think, so one of the opportunities coming up is, the IoT sensors, and there's, one of the partners in the program, Gearbox Lab, has some kits that have sensors that'll measure a number of qualities. And so kids will be, experimenting and I guess prototyping with some of that. And that may be, I think, an opportunity where I'm guessing having some outside mentors who might sort of at least be there as an authentic audience as they talk through their decisions as they're putting these things together, or what they're seeing, would be useful for you guys.
So that's for the teachers.
I lost. Okay, here we go. I'm back.
Yeah.
I don't know what's happening. So who came to the classroom, the same group that visited Audubon? Let me think. Oh, no. So that's different. I had the freshwater toolkit.
Yeah. Okay.
Okay.
Kate Donlevy.
Donlevy. Levy, like the levee should not break. Okay.
Yeah.
All right.
Riverkeepers visit you, Wade, or no?
No, K. Don Levy from Freshwater Toolkit.
Yeah.
I gotta admit, I am in a fog right now because I'm extremely sick.
Oh, you're sick? Oh, that's not good.
Well, I mean, not sick, just an annoying cold that I can't get past for about 2 weeks, and it's not COVID because I got tested twice. Just enough to make me miserable and confused.
Matt, how beneficial would it be for, I know how you measure water and a whole lot of other things, products is what you have, correct? How beneficial would it be for students to be able to see those products and how they work? In hopes that it would help them to think about how they will go about creating their prototype. Is that something that's feasible? Or more along the lines of assisting students? I'm trying to figure out how I can use you or utilize your company. Would it be from the standpoint of assisting kids through the process of developing a prototype? Or is there a possibility for them to, I know it's like apples and oranges, but to be able to view the products that you all have for measuring the water quality?
I think there are opportunities for both, right? So certainly if we're talking about sensor development, I think there's absolutely an opportunity to see what we already have from a sensor standpoint. Have our engineers talk about what makes them different or better or worse, or how we use the data and some of the applications of it too, because I think really the applications of the sensors are very important, because just making a sensor for the sake of the sensor is interesting in a learning process, but understanding what the value of what you're making is another level. And then certainly, there could be a follow-up after that on some mentoring or guidance on the process.
And I think that's what, Lalitha, that's what we think we would be most interested in as we move eventually into the prototyping component.
So you're starting with a kit that's already out there, or what are you guys starting from?
Actually, that's what we have to think about, and we're hoping at our next session next week we will get a better understanding of how to proceed with this. But right now we don't have anything, so it's like they have to create, they have to imagine, but before they do that, they have to be able to see some things that are already happening. So we don't have anything. Maybe a sensor.
From Milwaukee Riverkeeper, a person came with the kit, with the water. So the kids all tested for different things, in the classroom. And then we are going to take them for a field trip on December 1st and 2nd to go and see the Jones Island water treatment plant, so that they will have some idea. And they interviewed, only some of the students interviewed some professionals to learn about clean water. So we are getting there. So next step is correctly now Bdager Meter, so that once they have it, once they have the design, so that you guys can come in to help them,
Yeah.
So we have no materials or anything for the prototyping part. That hasn't been envisioned yet.
Right. So one of the program partners does have sort of Internet of Things kit. So Arduino boards and sensors and some code samples for putting together a device to test some, sort of continuous monitoring of water. So they would have sort of a temperature. I think it had dissolved oxygen and turbidity. They've got a set of sensors for that stuff. So the kids could start to put together, a working testing device. But I think it's sort of getting the sense of, well, what are the components that go in to something if you want to monitor water quality on a continuous basis, and then what do you do with that data? I think that becomes really useful.
With that, that's kind of where I was hoping we could go, because right now, like the sixth graders just got an idea of how water systems work. We haven't answered the question, what makes your favorite fountain? What is it about the water that comes out of your favorite fountain good, right? Why is it positive? So we don't know what are the qualities of good water for whatever purpose. That's what the teachers are asking for. Like, we have to develop what these parameters are. So I got to have someone come in and talk about what are the properties of water for whatever purpose you need, and what are the instruments that you use to do that. That's why I thought Bdager Meter would come in, right? Because we can go collect the water samples, or maybe even Mr. Stolen can order the kit for it. I don't know what this kit is, right? And we do have the capability of making that sensor if we hook up with what's his name?
And
Gearbox Labs. Yes, yeah. Right. So I'm not clear what I'm saying.
So I like the context of what makes your favorite drinking fountain your favorite drinking fountain. I mean, that's an interesting question, and one of which is tangible to the kids. Mm-hmm. I will say that Bdager, again, so you missed a little bit at the start, but we don't have, we're not a lab of which we have a mass spectrometer of which you're going to get, all of the different parameters. We're not a full wet chemistry lab. We have a certain set of parameters of which our devices will measure for. And there are a lot of them, but it's not, ours are more field installed, permanent installed sort of application products, not field test equipment, and not a wet lab. So there are things that we could do there, but like if you go out and look at Milwaukee Water's water quality report, I mean, it's a 15-page summary of hundreds of different parameters, right? And they have to put it out by guidelines, and it's all done through their water quality lab that they've got at Milwaukee Waterworks. So there are the full analysis of all the things, all the different metals, all different parts. We would be able to do a subset of those with our instruments. But we do develop instruments for inline, online, real-time measurement without chemistry, without wet chemistry. So we don't have reagent-based measurement technologies. It's not that you have to put a reagent in to do some conversion of what you're measuring. So that's really where our expertise with a couple of companies of which we've acquired.
Yeah. So Adrian, I think for your purposes, I jotted a note down to reach back out to Milwaukee Waterworks, because we had some of their folks
I got that note too.
On the interviews with Michelle's team, and I think we could, find somebody there to help come out and talk with the kids there about, well, what are the qualities that they see as impacting whatever qualities that the students perceive in the water.
Right. I think the Bdager Meter is a little above my understanding, I'll say.
Purview, above your
There
purview.
you go. Beyond my expert. I got to study a little bit to get what he was just talking about. Yeah. But I do understand now this water report. I'm hoping that Milwaukee Waterworks can just boil down, I don't know, just 3 things that the kids can measure with the samples we have. And I want them to be able to put it on a data collection Google Sheets, right?
Yeah.
Measure those things. What are the parameters? For math, I want them to understand that the smaller, more to the left of the decibel, the smaller the number is. And then the language arts, they're working on declarative sentences with evidence. So that's why I just want them to pull this data from the same thematic source. That's what my 6th grade teachers want.
Yeah, and I would imagine that if the kids can sort of describe why they prefer the taste of water in one fountain versus another, somebody from Milwaukee Waterworks could probably help tie that back to what bits of data might be impacting that, or what specific parameters that then you could go measure for. But Susan, you mentioned an interest in sort of the, seeing what goes on down in the lab as well. What are you thinking?
Start with me, Pete. So my question, how has Bdager Meter worked with schools or a school system, or is this something that we're reaching out and trying to find ways of how we can connect? At first, that's my first question.
So yes, we have. We've done brown deer is just down the road from us, so we've done certain engagements with brown deer historically. We've had other schools that were of specific interest, either from employees or whatever else we've done some work with, and then we've volunteered and had members on the board of STEM Forward pretty consistently. So we've had various volunteers participating in any of the activities that go on there. So we do. We're not giant, but we're not small. So, we have the ability to do some of this sort of work, but it's not a, giant portion of what we do either.
Yeah. So
okay. Go ahead, Pete.
So I was going to say, so if you're interested in getting kids down for a lab visit, Matt, I imagine you've got some parameters around that for how many you can handle at a time, what's useful to do, how much lead time you need to set something up. And
yep.
Sort of
in our Milwaukee office, our Milwaukee facility on the north side of Milwaukee on Brown Deer Road. I mean, that's one where we have the North America's largest indoor freshwater flow lab. Mm-hmm. So I can flow up to 10,000 gallons per minute in there. It's more meter based. It's not as much water quality based, but it's certainly around water. Yeah. And we've got plenty of capabilities there. We've got an auditorium to host 400 people. So it'd be about, do we get, some of the products and some of the people who are more specific to water quality at that facility, maybe, so we can host it appropriately. And again, I'm not saying we'd bring 400 people in, but just saying that it's by no means a problem to host some people up at our main campus. The water quality lab is much smaller. It's something like 1,000 square feet, a few desks in there and some workspaces. So it's a much smaller space where if we wanted to bring people in there, it'd be smaller groups, maybe 5 or 10.
Right. So in that case, if the teachers were hoping to get some input from the folks who were sort of working with those technologies, is that a Zoom call, or getting somebody out to the school is sort of a more likely way
if it's a classroom of 30 students, it might be what Pete is suggesting, turning it around and having one of the employees talk to the students by Zoom or coming into the classroom is probably logistically.
Can I tell you what I think I need?
Yes.
Sure. Yes.
So then my next question would be that I am no expert and I need a lot of help with regard to just water quality testing in general. So my end goal is similar, if not the same, to Michelle's, and similar, if not the same, to Adrian's, which that the goal was for them to create a prototype as well for me in the lab. Mm-hmm. So my students, we went to River Edge, they put the waders down, woo, 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 they got the water, and then woo, looked at the macroinvertebrates, hey, is it healthy? Oh, let's do that. So we did that, and then we want to do it closer to Milwaukee in March when we have the opportunity. But I want to do something more meaningful. That was meaningful. They loved it. Meaningful in that, so they understand how, I think that's what Michelle was saying, how these testing, when we do that, that's great. We have kits, we can order kits, we could buy kits, and I still want to do something to that end, but I don't know how that might be connected to Bdager Meter. And then my next question would be, I know you said something about the kits, but then, right, being able to help or assist or evaluate or give feedback, I think that would be, I feel like that's jumping a step, what you were saying, Yost or Pete, because they don't know what to do. They're going to draw a rainbow and say, this is how you're going to test the water, because the red is going to do this and the yellow is, how is that, you know what I mean? So how do we get from, okay, they're starting to have an understanding of healthy water. It's important, not just for the animals, but for us, some kind of testing, but I don't want to just, I can buy kits or maybe, whatever, and test. That there's value in that, but then really the end goal is that they create something. I don't know how to do that, but I'm willing to learn and learn with them, right? I don't have to know how to do everything. That's really the what this lab is about, that we learn together. Did I make any sense?
Yeah, well, so and so one question that raises for me is, Susan, would it be useful for you to go down and see the lab? So if Matt doesn't have much space to accommodate students, would it make sense?
Ding, sure. Yeah, that sounds good.
Matt, could you accommodate 4 or 5 teachers?
Yes. I would agree with that too, just so I can get an idea what things.
Thank you for interpreting me.
Yeah, what could the help? How can we help the interpret? What can we replicate in here? Right.
So let me do this because and not to turn this into a PowerPoint presentation, but let me. Oh, I'm disabled from screen sharing.
Here, let me.
Can I get turned on?
Yeah, hang on.
We selectively turn people on for that.
And I did put in the chat window to the link to the actual water quality report that Milwaukee Water has to publish.
Yeah, I saw that.
Oh, Yost, you're the host on this one.
Oh, I am. So I need to make you. Okay, all right. Let's see if I can do that.
It's so used to Teams. Security tab.
Yes, Pete. Yes. You should be good now.
Yes. Can you guys see that?
Not yet. Yes, now I see it.
Yeah.
All right. So I'm going to do a real flyover. Feel free to stop me whenever, but I don't want to turn this into a PowerPoint on our offerings. But drinking water monitoring can really be anything from source water, rivers, wells, whatever else, all the way through into the distribution system. And there's different parameters that are important at different points in that monitoring, depending on really where you are in that process. And we've got products and solutions for all those steps. Wastewater, same thing. There's different things you're going to look for. So whether it's right at the outlet from an industrial user or from a commercial property or whatever else, down into sewer monitoring. Sewer monitoring is actually becoming a really big area right now. Mm-hmm. In the UK, you'll see there's significantly heavy fines being levied on combined sewer overflows, because when a sewer overflows, it dumps combined sewage into the waterways. Monitoring for the actual wastewater treatment plant. You talked about Jones Island. So there's optimization of aeration. There's a whole bunch of things that you monitor for during that whole process. And then obviously effluent going back out into the environment to make sure what you're dumping into the environment is of appropriate quality. So products, we talked a lot about sensors, and you want the kids to develop sensors. So this is a bit of a range of what we've got. It's not everything, but it's the categories of them. Spectrometer, that is the one that measures light. And I see what he walks away, what Adrian was interested in light measurement. He walks away as I get to sensors. What's going on here, man? So spectrometers, that actually measures light absorbance. So they're shining a specific wavelengths of light through water. What the water absorbs correlates to different parameters of the water. So there we're measuring 256 wavelengths of light, absorbance of that light to correlate back to parameters. The other sensors here are more electrochemical, ion selective electrode, kind of standard products, pH, ORP, conductivity, things of that nature where you have an electrode reacting. A number of different terminal software and data backhaul, event detection, combined parameters, whatever else. Smart water, we'll get into that in a slide or two, but really products that are set up for distribution system monitoring or at inlets to a hotel, to a school, to whatever else to monitor the quality coming into a building. Mm-hmm. And then some accessories. We won't go too much into this because I think you guys all get it in general. Video that we could share later. Metronet being really one of the interesting products that ATI developed, low power, low cost, able to be distributed water quality monitoring. So these, you can have up to 8 parameters, can go all the way down into a boundary box. I know we live in Wisconsin where our meters are in the basement, but in a warm climate or in the UK or wherever else, your meter lives in a pit. We can actually do water quality monitoring down in that pit level at those power levels, cost, whatever else, for a few parameters. So maybe you want to monitor for chlorine and turbidity at the edge. We have products of which can do that at a reasonable enough cost, be installed and be long lived in those installations, perhaps at a pumping station. And then the pipe scan, really cool product that can actually mount directly to a pipe, hot tapped, so you can no water waste, optical probe within there as well. So you can do organics like total organic carbon, dissolved organic carbon, a few other parameters. UV254 is a great parameter for light absorbance to really be for organics. This would be a little expensive for really what we're talking about here, but it's a cool application of water quality monitoring in distribution networks. So Bdager just installed 16 of these. Valencia, Spain is installing 20 of them. So really distribution water quality monitoring is becoming more common. And products of this nature are allowing that to happen, whereas historically it's been more lab-based, more grab sample, take it back to the lab, see what was in your water, slow response time to a water incident. Here you're getting online, inline, real-time insights into what's in the water, and that's something that historically has not been available.
Yeah, and I think what's interesting in the last two slides, right? So if you think of the Gearbox Labs thing, it's going to be one sort of messy kit to test one thing. And with your last one, you had a platform that could take, I presume, 8 different sensors in those, which are the 4 on each side, right? And you might swap those out depending on what someone wanted to measure. And that's one profile for that solution. And then the next slide, you've got another one where it looks like you might also vary the sensors that are included in that, right? So how do we take these things and modularize them into a product that can be used in different ways? I think that's pretty cool.
Because that really is the part,
Yeah.
I'm sorry, what's that?
I'm just wondering if there is a simple product that you guys have.
So any one of these, any one of these can be taken by themselves into a simple little handheld that would have a readout. So you could take the conductivity or the turbidity or the chlorine probe, hook it up to a small display, and you could dip it in water and you could see the result.
This is a dumb question that I'm going to ask. Like you said, the spectrometer, it measures light.
Yep.
What other type of sensors do you use with your meters? I don't know if that's an appropriate question, but I'm going to assume all meters have some form of a sensor. So what type of sensors are you guys using? And I'm most interested in the, not industrial, but the river and drinking meters that you've created. What type of sensor?
Yep. So within here, there could be a number of different core principal sensor. So a lot of these are membrane diffusion, and I apologize if this is overly technical as well, but there's some sort of electrochemical reaction occurring in a lot of these. So you have a let's say it's chlorine. You have the chlorine ion diffusing through a membrane, reacting with an electrolyte, causing an electrical change, of which we're then amplifying to get a readout. So it's a chemical reaction happening across a membrane that is electrochemical, and you're then taking that electrochemical signal and amplifying it and converting it into a linear response or some other response to get a readout from the sensor. So that's one example. There are light ones. There are anodic stripping voltammetry. There's a number of core principles of which you can use, but they're all specific to the parameters of which you're looking to measure. So that is where, it's not, water quality isn't a simple, you're going to use this and get the quality of the water, because, lead right now requires reagents. You have to do some wet chemistry with lead in order to convert it into another parameter to get some reaction to then measure it. So a number of different core sensors. And so even like our flow meters right now use either ultrasonics, where we're looking at time of flight of how long an ultrasonic pressure wave takes to travel upstream and downstream. And we're able to infer that into flow rate. That's technically a quality of the water, but it's a different core principle used to measure something about the water. And I think all of this ultimately comes down to physics and chemistry, and different things will pick up different parameters. A pressure sensor is looking for, deflection of a diaphragm, looking for strain to correlate to how much pressure is in the pipe, pushing on that known thickness of material, right?
Thank you, because when kids start to create their prototype, they're going to have to know what type of sensor to use for the variable that they're looking at.
Right. Absolutely.
Yeah. And so that's why I asked that question, but I need to make sure, I guess, Gear Up or those folks can kind of help us more with what type of sensors we would need to introduce to the kids. But if they were able to see something real and how it works in the real world, with people who are in these careers, then when they do their prototype, it will make a little more sense to them.
Yeah, well, and I think that the fact that you can't do the continuous monitoring of lead in water, you've got the possibility with all these other variables, right? And you can't do it on the one that you might really care about. That's a kind of sort of motivating thing that I think could inspire some kids to be thinking about this stuff.
And you technically can, but you've got reagents and a heck of a lot of expense. And the problem with lead is it's a last 100-foot problem.
Yeah.
So it's not coming from the distribution system, it's coming from that lateral. And so to measure it at your home is something that the cost, the complexity, the power, everything else, it just, you'd have a $40,000 piece of equipment at each house, and that just
Hence why we're sticking to turbidity, pH, and air water.
Yeah, but Michelle, you just got kids excited about what happened in Flint, and they want to avoid what happened, that to happen in Milwaukee. So you got to.
Then we're gonna bring it down and say what can we control.
But that's actually still a good use case though, because what happened in Flint wasn't because of the lead pipes. The lead pipes were there long before Flint happened.
Yes, right.
What happened in Flint was because they changed water sources that had different conductivity, had different, used a different disinfectant, which now eroded the biofilm and leached out all the lead into the water. So it was a decision made by the water operators to change other water quality parameters of which we can measure for that caused the lead to go into the water system instead of being contained in a biofilm and underneath an anti-corrosion agent.
Mm-hmm.
So that is where you monitor for what you can monitor for to make sure you're delivering appropriate water. If you had the appropriate chlorine levels, the appropriate conductivity, everything else, you wouldn't have had the issues that occurred in Flint. The long-term solution is still to replace all the lead pipes, but you could have been monitoring for the other parameters.
But there's no way back for Flint now that the biofilm has been compromised and so on. You have to start replacing the pipes, but you don't have to get to that level, that situation in other cities if you manage how you clean the water before it gets there. Is that how I understand it?
Yep. Yeah. So just an example of some of the use cases. This is chlorine monitoring. I don't know if it's at Severn Trent. It's in a UK water utility, but essentially this is 4 different points throughout a distribution network, and you can see the chlorine residual falling off as you go through the distribution network. And you can also track a spike of chlorine through the network as you go. So you can see now in the UK, you would get fined for having too much chlorine in the water because they get fined for taste violations and everything else. So going back to why is your favorite drinking fountain your favorite drinking fountain? It could be chlorine related, could be the metal that's actually used inside of that drinking fountain versus another one, leaching out some things into the water. Mm-hmm. Here we talk about turbidity and chlorine. So this was, again, distribution system monitoring, but a spike in turbidity corresponding to a dip in chlorine. As that turbidity spiked, that introduced organics into the pipe, of which consumed the chlorine, residual chlorine. So the chlorine falls off as it's being used to kill off the new introduced organics from the turbidity, and then a resumption to normal levels. So, again, some of those real world examples of what you might look for in a distribution system and disruptions. This was likely caused by an opening of a fire hydrant, flushing of a system, something that sloughed off a lot of that film on the wall into the water, and then resume back to normal. But again, having insights to the fact that it happened, so operators can better manage their water network. And then we talked a bit about parameters. In general, these are the parameters of which we can do throughout our suite of products. Some of them are surrogate figures that are derived optically. Some of them are actual direct approved EPA method sorts of products. But again, that's a whole nother ball of wax. But even if you came up with a great sensor, it has to be approved and validated method by the EPA to be accepted as a actual result.
Michelle, did you have your hand up? You want to ask a question, or was that?
No, I was just saying that would be just over the head. We wouldn't be looking at that. But I did post something in the chat saying that thank you for clarifying the real source of that Flint issue. And I think if we take it down to that level, Letha, then looking at the smaller variables will be more meaningful still to the kids. So I think that's interesting.
Yeah.
That's interesting. I have to leave in a few minutes, Matt, and I was just taking notes. I think you've helped me to clarify where we're going to go with this and how we can use Bdager. I'm still interested in the kids at least taking one or two of your meters that have sensors in it and them being able to hear how it works without going into the technical too many details. And then from there, having the students to look at the types of sensors that is available for them to consider for the project, and then beginning to design and construct their prototype so they can look at turbidity, air water, or some of those smaller ones. And if your people could, even if you show the teachers or something, so we have more background. And then if we get some volunteers, it would be really nice when the kids are going through that process, if someone could come in and help them with the designing and the constructing of their prototype. So I think I'm so focused on the prototype, but that, like I said earlier, having that background of what's happening in the real world and what you guys are doing specifically with the river, Letha, I think that's what our focus is going to be with the river, because we're going to constantly go and retrieve some water from one of the rivers, and the kids are going to test it monthly. So I think that's the direction that I'm going, which is what we planned from the beginning, Kryler. What we planned from the beginning, that's what we want to happen. I think I think I'm more clear now of how I can use Bdager. I like your presentations, how you showed the different levels, industrial, river, and drinking.
Right.
I really like that because it's going to eventually narrow it down to what we want the kids to do. So that presentation was good. We just have to kind of make it.
We got to middle school it.
Yeah, we got to middle school it.
Yep.
That's what I would be interested in, because that was interesting to me.
You'll middle school it.
Yeah. So I would be interested in Letha. I don't know if you're on the same page still with me.
Yeah, Matt, would you be able to share the presentation with us? So
that's too complex. We need to simplify it.
I want a slide. I just want one of the slides.
We got to go for a visit first. We have to go for a visit first.
Yeah.
Okay, and then say, okay, can somebody talk to the kids about this one, and that one?
Right.
Yeah, would that work for you, Matt, if we sort of look for some times?
Yep.
What are we talking about in the next few weeks, or in December, or?
Well, I think as we get, we're still doing some background information and stuff. I think as we get closer to ready for the prototype in December, Letha, is that what we're looking at? December?
It's okay. We can go even now because it's us.
Yeah.
It's not going to be ready in December because when the weather is good, I want to go, We are done by around 4:00 at our school. Brown Deer is very close by.
The teachers. The teachers need to be up and rolling right away. Yeah. The teachers anytime.
Right.
But I would like
I agree.
For interviews
right
for the students.
Yeah.
I want to set up interviews for the students.
So we are ready to come even tomorrow. So if you can set up something, because we are done.
Matt's at home. He can't host you at the office right now.
I was at the office today, but I came home. I was at the office at 5:30 this morning, so I came home a little bit early.
Matt's an early riser. He told us that before. Yeah.
So Matt, if you're thinking afternoon, I'm hearing after 4:00 would work for a visit just for the teachers. Do you want to take a look at, calendars and who might be around, and sort of suggest some dates, and we can coordinate with the fellows and sort of get something set up for that first step. And maybe that's a chance to talk through what would be useful in a presentation for sixth graders to help.
Are your schedules more flexible than that possibly? Because I know, I mean, I create my schedule. I know Mr. Wade does. I know you guys have class after class, but you can, Michelle, you can say you have to be out for this professional development. Come on.
I think Lolita can, but I can't. I have students. I'm back in the classroom, Susan. I have 5 classes to 4:15.
So my personal schedule for November is pretty full. So actually Sunday I fly out for Tacoma, Washington to the Water Quality Technology Conference, which is actually a really cool conference. If you think this was over your head, I mean, the guys are intense, but
yeah, we won't ask you to bring anything back because it won't matter.
So then we've got our board meeting at the end of next week. I'd have the 15th, 16th potentially open to do something. And then I'm on personal vacation from the 17th to the 23rd. And then we've got a summit on site with all the water quality team out in Collegeville, Pennsylvania, and then back here at the end. So if the 15th or 16th were an option, I think that would work best for my personal schedule. Otherwise, I can certainly get you hooked up with John McLean, who runs our water lab, and just have him take it if those days didn't work for you all.
The 16th?
15, 16.
The 16th would work for me. Tyler, Adrian, the 16th of November.
I'm looking at my little, I gotta pick the right calendar.
I'm looking too.
On my phone. Because that's, where am I? Because my phone has my master calendar. One calendar to rule them all.
16th is fine for me.
Yeah, 16th is fine. 15th is fine.
The 16th is better for me.
16th it is? That's good.
And so we will meet you at your Brown Deer location?
No, so where we would go, I think, is down to our 3rd ward location, which is the water quality lab.
Never mind. My bad. I just instinctively.
What time? What time?
I'm actually pretty open. I'd have to confirm with the person who runs that lab, but his schedule at least looks open. I don't know if he's got one schedule to rule them all, Adrian, but at least the one that he keeps in Outlook looks like it's open. So I'd be fine whenever. I can make whatever time work. If it's 4:35, if it's better to do it.
Yeah, it has to be 4:30 because if it is Brown Deer, it's only 5-minute drive, but it's downtown. It's a 15-20 minutes drive for us. So.
Yep.
Okay, so we'll look at the 16th. And it's Bdager Meter.
As Adrian is coming from, you have flexible schedule. I'm sorry.
I'm really close.
I'm gonna be out there early. I'll meet you at the bar.
Wicked Hops right around the corner.
Is that what third ward means for you, Adrian?
That's what I'm thinking. We can talk about the turbidity of Pinot Grigio versus Pinot Noir.
Oh my goodness.
We'll make it work.
So you joke about that, but one of our guys from the SCAN acquisition, part of his demo is actually using different wines in the optical sensors to show what different region the wines were grown from based on how they absorb light differently.
That's what I'm talking about. Application. Then I understand and I can teach the kids. We'll just
there's a use case in this.
So essentially these are the wavelengths. This is the absorbance. And so you can tell the different parameters within some of the alcohols based on how the light's absorbing through that probe. But anyway,
you have my rapt attention.
Go off, Mr. Wade. Look at that.
Yeah.
All right. So 4:30. I can send out the address. Let me confirm with our other colleague that we can do it, that we can host at that time. But 4:30 down in the 3rd ward. I'll get the address out, and it'd be just for really this group of teachers then.
Mm-hmm. Yeah, and if you want to just throw a calendar invite out for Yostra, we can just forward it to the teachers, and then you'd have their contact info as well.
Yeah, I'll probably, it looks like I can join you. I'm not a teacher, but I'll ask the dumb questions and make the teachers feel good.
We'll allow it. And then there are obviously opportunities to get to Brown Deer if you guys are just down the road too. If there's something else we want to see at that facility, it's an impressive lab. It's giant, but it's not as water quality focused. So it's more flow related. Not that we wouldn't be able to get equipment there as well.
Yeah.
Mm-hmm.
You said
certainly
more
IoT though. Also, I mean, we've got a heavy focus on IoT. So we've got millions of cellular devices out there collecting data, aggregating it back into a software system of which is being used to present to both homeowners for their water usage on 15-minute resolution, as well as to the utility to generate a bill, identify leaks, whatever else. So there are applications for the IoT aspect of how we hook that up to various sensors that might be out in the real world.
Mm-hmm.
Neat.
So down the road, certainly worthwhile to contemplate going over there too.
We really appreciate. Thanks,
Yep,
Matt.
no problem.
Thank you. I appreciate it. I appreciate it.
Have a good night, everyone. Yep.
Thank you.
Thank you, Matt.
So much.
Thank you.
We'll follow up with you.
It was nice. That was very nice. Thank you, guys. I have to go pick
You're
up
welcome.
my kid.
Yeah.
All right.
Good.
You see
Bye,
this?
Go get Nala.
I
You
escaped.
did not go there.
Susan, do you see this, Susan? I
Yeah,
did it in Minnesota with the girls.
awesome.
I was
Nice.
facilitating.
Yeah.
Y'all know what this is, right? I escape.
I escaped the
Yep.
escape room. Yeah.
I did. I was a bunch of young people. I was just facilitating.
We know.
Get out in time. Yeah.
We sure
how-
did.
how
I think
many
we
minutes
had
did it take
maybe 30 seconds remaining.
Okay.
All right.
You did it.
Yeah.
All right, Michelle.
Well,
Okay.
good night. Thanks.
Hey, that was wonderful. I didn't understand at the beginning, but I got a better understanding.
Yeah.
I knew
Oh,
I
thank
needed
you.
to come to help as well,
Oh,
to kind of clarify.
Excellent.
All
Yeah,
right.
so Adrian, I'll reach out to the water folks at Milwaukee, see if we can line somebody up.
Okay, yes. I was thinking about that, the waterworks people. I got that report. I'm just saying, can we get two things that the kids can measure?
Yeah.
That's
yeah.
all.
All right.
Exactly.
Thanks,
That's
Susan.
what
Good to
I'm
see
saying.
you.
All right.
Good
All
night.
right.
Thank you.
Bye-bye.
We'll talk to you later. I gotta run too.
Good night.
Good night.
Bye. Good night, Adrian.